Hey everyone, welcome to the rcprinter.com YouTube channel. Very excited today to get started on this build right here, which is the OpenRC Tractor. I've never built one before, so this is a first for me. So looking forward to working my way through any issues I encounter, and hopefully you guys can learn from that and build one for yourself. So stick around and enjoy.
Okay, here's everything you're going to need to complete this project. First, you're going to need all these printed parts that you can find at myminifactory.com for free, or you can access them through the developer's website at MakitPro.com. I'll have links to those in the description below. Everything you see here is printed in simple, cheap, easy to print PLA, except for these large tires here which are printed in TPU. We've printed the parts and have the materials for the 2019 updated version of the tractor, and I suggest you print the updated one as well. You're going to need a 3 to 9 volt DC motor which outputs approximately 176 RPM, a differential gear, two 5mm LED lights, a 30 amp miniature brushed electronic speed controller or ESC, 3 micro servos, a small 2S 7.4 volt LiPo battery, some bearings, 6 8x12 by 3.5mm bearings, and two 18 by 12 by 4mm bearings. Please note those are the same as the ones on the OpenRC car. Radio and receivers, some 2-pin JST connectors to power the motor and any implements you plan to attach, a servo Y, a servo reverser, some M3 rod to make links and some M3 rod ends, and an assortment of screws and nuts. Check the official BOM for a total count. Now that we've got everything together, the first thing we're going to do is install a rear differential. Before installing the rear diff, just make sure that it works. You may need to loosen the screws a bit to allow it to spin. You should be able to turn it with just your hands if you put in a bit of effort. If you can't turn it at all, it's too tight, so loosen the screws and try again. Next, we're going to get the two differential brackets and put M3 nuts into the two crevices in each one. Then we're going to slide a bearing into each of the diff brackets and mount them on the diff. Make sure the wider bottom part of the brackets extends towards the outside. Now mount the diff brackets onto the upper chassis part 2 with 4 M3 screws. Next we need to attach the motor, but first we're going to solder a JST connector to it. We're going to get a blob of solder onto the connection, and then we're going to attach the first wire. Now the other side. There we go, looking good. Now we can attach the motor to the motor bracket with two M3 by 8mm screws, no longer than 8mm or they'll bind the motor. Next we need some extension cables for the implements that are going to be attached to the back. I don't have any, so I'm going to make some. We need an extension servo cable and an extension JST power cable, so I'm going to solder a couple together. There's the extension power cable done. Now we're turning a servo Y cable into just a regular extension cable. And there's the extension servo cable done. Now we're going to run the cables from the two servos, the male end of the servo extension cable and the female end of the JST extension cable, through the upper chassis part 1, then under the diff in upper chassis part 2. Now we're going to arrange the wires neatly and put the two halves on top of each other. Okay, now we're going to insert one of the smaller bearings into the gear bracket for the pinion gear. Then you can add the pinion gear and set it in place for the moment. Next, we'll take the motor coupler and slide the keyed end onto the motor shaft and the other end onto the pinion shaft. We'll lock the pinion onto the coupler with an M2 screw that'll go right through the coupler. And then we'll put it into its place so the gears mesh and make sure all the wires go neatly underneath the motor housing in the groove provided. Now we're going to screw down the gear bracket with an M3 screw on either side and 2 screws underneath. Now we can screw down the motor housing from underneath with 4 M3 screws. Now flip it back over and push the pinion gear into the differential gear to make sure they're meshing nicely, and then use a short M3 screw to lock the motor shaft coupler into place on the motor shaft. Then test to make sure everything is still meshing nicely. Now we're going to put 2 M3 nuts into the crevices at the back of the chassis, and then lock together the 2 chassis halves with 2 M3 screws. Now we're going to slide the larger bearings onto each of the rear axles. You may need to sand them down a little to get them on, as I've done here. Then slide the axles into place and make sure the bearings fit nicely into their slots. Secure the axles to the differential with M2 screws that go right through the shafts. Play with everything a little to make sure it's all tight. You can even connect a battery at this point to make sure everything is meshing well and your differential is allowing each side to spin on its own. Okay, so now the drivetrain is finished and we can start building the front end. Grab the front bridge and insert a front axle holder on each side and secure each side with 2 M3 screws and M3 nylon lock nuts. Now take the 2 front axles and secure them to the holders with 2 longer M3 screws and nylon lock nuts. Make sure they're not too tight as they'll need to rotate freely for the steering. If you've used screws that are too long like mine, trim any excess with a Dremel as I've done off screen. Now take the front dumper, the little triangular piece, and attach it to the bottom of the front chassis with 2 countersunk screws that go through the chassis and into the dumper block. The dumper block gets 2 M3 nuts inserted into it that you can screw into. Now you can simply attach the front bridge assembly to the dumper with an M3 screw and a lock nut. Again, make sure it's not too tight so it can rotate. Now we're going to create our steering arms, and for that we're going to use M3 rod and rod ends. To do this, I'm simply going to take the full distance between the center of where the axle pivots, and then divide by 2 and make 2 arms of equal length. My distance was about 114 millimeters, so I'm going to make 2 arms that are 57 millimeters each when measured to the center of the rod end balls. Based on the length of the rod ends I have, I'm going to need to cut some rod lengths approximately 41 millimeters. This doesn't have to be perfect, as I can increase or decrease the actual length of my steering arms by rotating the rod ends once they're complete. Once the rods have been cut, clean up the ends a bit so there's no jagged bits, and then thread the rod ends onto the rods until the desired length is reached. Again, in my case, we're looking for about 57 millimeters. Check your work to make sure both steering arms are the same length. Now we can install the servo and connect the steering. Place the servo in its bracket and screw it down with some M2 screws, or hopefully just the screws provided in your servo package. Then take the 3D printed servo arm and sandwich it between the steering arms and screw it all together with an M3 screw and nylon lock nut. Make sure it's not too tight so the servo arm can move freely. Place the steering assembly on the underside of the chassis and then connect the steering arms to the axles with an M3 screw and lock nut on each side. Make sure the channel in the servo arm faces towards the center of the chassis. Put your servo horn onto your servo facing downwards, and then connect the servo arm and the servo horn to the servo with either a screw that came with your servo or another M2.5mm screw if it didn't come with one that's long enough to reach through both. Now flip it over and attach the servo holder to the chassis with two countersunk M3 screws. Then check to make sure the steering moves freely. Alright, the steering's complete. Now we're going to grab the front light bracket and attach it to the front grid with a short 8mm M3 screw. Be gentle, as this is easy to strip. Now we can attach the front grid to the chassis with a couple M3 screws and nuts. It's a bit finicky, so just have some patience. I found it's easier to do one side first and then the other, as my nuts kept falling out of place. Now we can install the front wheels. They press fit together pretty easily like this. You can add one small bearing to the outside and one to the inside of each wheel, and then secure them to the axles with a printed wheel nut and a countersunk M3 screw. The printed wheel nut is keyed, so make sure it settles nicely onto the axle before screwing it down. And don't over tighten the screws so that the wheels can spin nicely. Okay, so we've got the front end and back end mostly complete. Now we can start adding some body pieces to make it look like a tractor. Grab the console and attach it to the lower chassis with two M3 screws. Be careful not to over tighten. Then grab the steering wheel and attach it through the console with a longer M3 screw and a nylon lock nut, making sure there's still play so the wheel can turn freely. Now grab the rear chassis and slide two M3 nuts into the slots you see here for connecting the lifter arms later, and then place the lower chassis on top and press together to seat the bearings completely. Screw together the chassis pieces with two M3 screws and nuts. Now check to make sure everything still moves nicely. Next, we're going to mount the two lifter servos that are hanging out the back with M2 screws or the screws that came with your servos. The gear on the servos should be oriented towards the back of the machine. Attach the seat base above the servos with two M3 screws as shown. Place the seat back onto the seat and slide through two longer M3 screws. Add the rear arm holder under the seat on the screw closest to the seat back. Put your springs onto the screws and place the whole assembly onto the seat base and then screw it into place. The spring should be slightly compressed when installed. Okay, now I'm going to fiddle with my wires for a bit, and I'm going to try and get a couple centimeters of the extension cables hanging out of the back for our implements to attach to. And I'm also going to try to remove the excess slack from the rear lifter servo cables to make sure we can attach the rear plate nicely. Once you're happy with your cables, you can slide them through the rear plate and then set it into place. Now we're going to insert two M3 nuts in the bottom of the chassis and then screw down the plate with two M3 countersunk screws. Add two more M3 screws through the top part of the rear plate and into the chassis plastic. Now we're going to attach the rear lifter arms to the servos and chassis. A quick note here that you can either buy these or you can make the rear arms the same way we made the front steering links. I built my own arms, but I actually made my arms too short and had to use longer rod later on. So make sure you make them the required 95 millimeters in length between the center of the balls. So to connect the arms, we're first going to add a rear arm bracket to each arm by removing one rod end, sliding it on, and then rethreading the rod end. Next, I attach the printed arm to a servo arm with an M3 screw and nylon lock nut, leaving it loose enough to pivot freely. Make sure the groove in the servo arm will point towards the center of the vehicle. Then attach the printed arm to the metal arm bracket with another M3 screw and nylon lock nut, again leaving some play. Then do the same thing to the other side. With the rear lifter arms now complete, you can attach them to the chassis with an M3 screw. I found when I installed my arms that the lower connection didn't line up perfectly with my servo connection and was causing undue stress on the servo arm. So I added two nuts to the inside of my M3 screws here as spacers before tightening the screw into the nuts in the chassis that we inserted earlier. Now attach the servo arm to the servo with an M2.5 screw or a screw that came with your servo. Now I'll attach the other side. Alright, now we're going to connect the front and rear chassis halves together with two longer M3 screws and nuts. Okay, now we can connect this rear hook rectangular piece to the rear plate with one longer M3 screw and a lock nut, making sure it can still rotate freely once installed. Again, if the screw you use is too long, just trim it off with a Dremel. Next we can work on the front motor panels. First we're going to attach the exhaust or escape to the left motor panel with an M3 nut and screw. Then we can attach the 2 motor panels to the front chassis using 3 shorter M3 screws and 3 regular nuts on each side in the holes provided. Okay, now we can add the fender arms to the fenders with 2 M3 nuts and 2 countersunk M3 screws on each side. Remember, if you're running out of short screws like I was, you can just use some longer ones and then trim them off after. Easy peasy. Now we're going to attach the fenders to the chassis by inserting 2 M3 nuts into the fender arms and then attaching them to the underside of the chassis footbed with countersunk M3 screws that go through the top of the chassis footbed. Now do the same for the other side. Alright, we're finally ready to install the rear wheels. The tires pop onto the rims just like the front ones did, and each wheel keys onto the drive shaft to hold it in place as the axles spin. Add a 3D printed wheel nut to the wheel, and then tighten it down with a countersunk M3 screw. You didn't want the front wheel screws tight so the wheels could spin, but the rear ones can be snug. Just be careful not to strip the plastic. Okay, we're almost done, and it's really starting to look like a tractor now. But now we need to add on some of the finishing details. First, screw the light bases into place using tiny M2 screws, and then glue on the lights with some super glue. I find I often strip the tiny little M2 screws. So if I strip one, I just cut a little groove in it with a Dremel, and then I screw it in the rest of the way with a flathead. Seems to work pretty well. So next we're going to attach the badges to the hood with a little more super glue. I opted to tape them in place with some masking tape while I was working, so that they don't move and they can dry solid, but it's not really required. Then we're going to attach the air filter with a dab of super glue as well. The air filter goes up on top of the hood towards the rear left side. Finally, we're going to add a bit of super glue inside the front section of the hood where the front badge is going to sit to hold it in place, and then just snap the front badge into the grooves that exist to seat it. And now we're going to set it aside for a few minutes to dry. Alright, now we're going to set up the lights. To do this, we're going to take 2 5mm LEDs and solder them to a male servo end. Now we're going to install the lights into the front grid by gluing them into place with a dab of hot glue. Make sure to hold them in place until the glue sets up on each side. Okay, so now the last thing to do is hook up all the electronics. You can do this in whatever order makes sense to you, but here's what I did. First, I attached a servo reverser to one of the rear lifter arm servos. Quick note here that when connecting your servo wires, make sure that the colors of the wires match up, or things won't work as advertised. Next, we're going to attach a servo Y to the servo reverser and the second rear lifter arm servo, so they'll be connected to the same channel on your receiver. Then you can connect the servo Y to the channel you want to operate your arms in your receiver. Next, I grabbed my ESC speed controller and I hooked it into my receiver. Likely it should go in channel 2. Then you can connect your speed controller to your motor with a JST plug. And then you can connect your battery to your ESC, for which I created a JST to T-plug dongle. Then you can connect your steering servo to your receiver, likely in channel 1. And finally, you can connect your lights pretty much wherever you want because they're not going to be controlled, they're just going to get some power. Now you can stuff everything inside of the front compartment, turn on your radio, and then turn on your ESC and watch everything come alive, and then do a little test run to make sure everything is working properly. Congratulations, your tractor build is complete. Let's go and take it for its first spin.
Alright everyone, thank you so much for watching our build guide of the OpenRC 3D printed tractor. We hope you found it very useful. And obviously since building the tractor, we've gone ahead and created a few more implements that we can use here. We've got a 3D printed working fertilizer spreader connected right now. We have this cultivator here, and we've also created this leveler as well. So hopefully in the not too distant future, we can upload a video of all of these implements in use, so make sure that you subscribe so you get notified as soon as that happens. And as always, if you're looking for cool 3D printed RC projects to build, guides on how to build them, kits, or parts, check us out at rcprinter.com.